This video is over section 7.2, Introduction to Polynomial Functions. There's quite a few vocabulary words that we need to understand before we can work any of the problems. And so the first thing we need to define is a polynomial function. I'm going to write very, very tiny, so hopefully I can fit it all into this box. But a polynomial function, it says let a sub n minus 1, a sub n minus 2, all the way to a sub 0 represent real numbers and n minus 1, n minus 2, all the way to 0 represent whole numbers. Then, I'll go to the next line. Then a function defined by f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a sub n minus 2 x to the n minus 2 plus plus a1 x plus a0 or a naught is called a polynomial function. Okay, so just to explain a little bit, we have our function. These are all the big numbers in front, or the coefficients, with a sub 0 being the constant at the end. And then this would be like x to the fourth, x to the third, x squared, and so on. So these would be, the pink would be all of the just variables. So I'm going to delete the pink, but that's what's going on. Okay. Leading term is the term, we'll just say the term a sub n x to the n. So this first term is called the leading term. The leading coefficient is just the number part, or the real number part, the a sub n part. Oops, sorry. Okay. The exponent n is the degree. So this would be the largest exponent. End behavior is a little bit more complicated. It's going to make more sense once we work some problems. But some things that we need to talk about, when we see x with a right arrow infinity, this means as x goes to infinity, and then x to the negative infinity would be as x goes to negative infinity. Okay, so in behavior, we are discussing what's happening on the graph as x goes to infinity and x goes to negative infinity, and then I'll use a different color here, but this means as x is going to the right, and this would mean as x is going to the left. Okay, and then I'll draw some lines here. When we're discussing that, we're figuring out what y or f of x is doing. So this would be, if I have f of x to infinity, that means f of x, forgot the infinity. If I have f of x is going to infinity, that means that f of x approaches infinity. And similarly, if I have f of x goes to negative infinity, this would be f of x approaches negative infinity. And I guess here we probably should have said approaches instead of goes to. I guess I'll change that real fast. Okay, sorry, writing really tiny. All right, a cross point, again, will make more sense when we get into some problems. So if C is a 0, and I'm going to put in parentheses x-intercept. If C is a 0 of odd multiplicity, then the graph crosses the x-axis at C. And we're going to see examples of that when we do some problems. I just wanted to get that down. Okay, if C is a 0 of even multiplicity, and again, that's an x-intercept, then the graph touches the x-axis at C and turns back around, so it doesn't cross. Okay, the intermediate value says let f be a polynomial function for b less than a, or sorry, for a less than b, if f of a and f of b have opposite signs, then f has at least 1, 0 on the, I'm running out of space, interval a to b. Okay, a ton of information there. Let's work some problems and talk about some of this. A lot of vocabulary words within the vocabulary words, so let me just highlight a few things. I'm going to highlight, if we refer to a 0, it's sometimes called a 0, but that is an x-intercept. Multiplicity is used in here, which we're going to talk about more as well. And then the intermediate volume theorem will come too. So just want to say that we will discuss what those mean. All right, so if the degree is even and the leading coefficient is positive, what that means is our graph is going to be pointing up to start. It might bounce around a bunch, but it's going to end pointing up as well. Okay, so it could be just no loops, it could be 2 loops, but it's always going to end pointing up. If the degree is even, leading coefficient is positive. Okay, for this next one underneath, it says the degree is even because it's in this column. I should have made, I guess I can do it now, made this column thicker. Okay, so these are separate. Okay, so if the degree is even and the leading coefficient is negative, we're going to start down. A lot of stuff's going to happen, but it's going to finish down. And maybe nothing really happens. Maybe it's just one loop, but it finishes down. Okay, if the degree is odd and the leading coefficient is positive, we're going to start down. Some stuff might happen, and it's going to finish up. Sorry, that's so ugly. Okay, if the leading coefficient is negative, it's going to start up. Some stuff might happen in the middle, but it's going to finish down. Okay, so the degree is, again, the highest exponent. So up here, degree is the largest exponent. Okay, leading coefficient is the number in the very, very front that goes with that largest exponent. Okay, so let's talk about end behavior for these. So if the degree is even, the leading coefficient is positive. as x goes to negative infinity, so that's the left, f of x approaches positive infinity. And I'm going to put a positive there so we can see. So that means on the left side, I guess let me use some colors here. So on the left side, we're pointing up. Okay. On this side, as x goes to positive infinity or right, f of x is pointing up, so f of x is also going to positive infinity. So I'll use a different color here. We can use green. So on the right side, it's pointing up. Okay, for this one, we're going to have as x goes to negative infinity. So on the left, f of x is approaching negative infinity as well. So that one would be pink because we're looking at the left. Pointing down, f of x or y is pointing down, so that would be negative infinity. All right, as x is going to positive infinity, f of x approaches negative infinity, so it's pointing down on the right. So as x goes to the right, f of x points down. All right, for the odd degree ones, as x goes to negative infinity, so on the left, f of x goes to negative infinity as well because it's pointing down. So on the left, it's pointing down. Okay, for this one, as x goes to positive infinity, so as x goes to the right, f of x is going up, so positive infinity. Okay, last one, when we have a degree odd, leading coefficient negative, as x is going to negative infinity, so on the left of our graph, f of x is going up, so that would be positive infinity. And as x is going to positive infinity, so as we're going to the right, f of x is going to negative infinity or going down. Okay. This chart is something that you could memorize, but the more problems you do, you'll just kind of start to understand, okay, odd, even degree, they're pointing in. If you notice here, let me see what I can do. If you notice in this left side, the even degrees are pointing the same direction. So they're both pointing up in this one, or they're both pointing down, depending on if the leading coefficient is positive or negative. Okay, if we're looking at odd functions, they're pointing opposite directions. So it's either they're pointing down and up if the leading coefficient is positive, pointing up and down if the leading coefficient is negative. Okay. All right, use a leading term to determine the end behavior of the graph of the function. So we need to make sure that this is in order, and we do have x cubed, x squared, x, and then no x, so it is in order. So here we have the leading coefficient is negative 5.6, and the degree of our polynomial is 3, which is odd. Okay, so we have a negative leading coefficient and an odd polynomial. So when we go up to our chart, we're looking for a negative leading coefficient and an odd polynomial. So that puts us in this bottom right box here. Let me highlight that so we can look at it. So we are not really sure what's going on in the middle of this polynomial here, but we know that on the left, the graph is pointing up, and on the right, the graph is pointing down. So we can just copy and paste these end behaviors to our graph. So we know as x is going to negative infinity, or on the left, we know the graph is going to be pointing up. So f of x is approaching positive infinity. And then on the right, so as x is going to positive infinity, f of x or y is pointing down, so negative infinity. Oops, I got that backwards, didn't I? Oh, no, I didn't. Yeah, so it matches that yellow highlight. Awesome, erase that. Okay, for the next problem, it says g of x equals 5/3 x minus 3 to the 6th, 2 plus 1 cubed, x minus 3. Okay, so there we could do a lot of math and multiply this whole out, or we can just find what the leading coefficient would be and what the degree would be. So if I'm thinking about the leading coefficient, that's all of the numbers in front of variables. And for sure, I'm going to have this 5/3. There's a 1 here. There's a 2 here. Okay, and this is going to be x to the 6th. I'm sorry. Let's start with that. Okay, so if we have 5/3 times 1, and then there's a 1 here, we have times 1 to the 6th power, because there's a 6 here, and then we have 2 to the 3rd power, and then we have x to the 1 power, just a 1 here. So the leading coefficient, it doesn't really matter what number this is, but we know it's going to be positive. So I'll highlight that in yellow, but we know the leading coefficient is positive. It does not matter what it is. There's no way for all of what we looked at to give us anything negative. Okay, the degree is a little bit tricky. Oops. When we're just looking at this, we could multiply it out, or we could say, okay, we have x to the 6th, and we have 2x, but let's just consider x to the 3rd, and then we just have an x here. So when we multiply that out, x to the 6th times x to the 3rd times x would be x to the 10th, or even. So our degree 10 is even. And again, we just care about even and odd. We could multiply all that out. I don't want to. Okay, so we are looking at, on our chart, where the leading coefficient is positive, it's even. So I have no clue what this crazy function is going to look like, but I know that my end behavior is going to be this box right here, because the degree is even and the leading coefficient is positive. So for end behavior, as x goes to the left, f of x goes up. So as x goes to negative infinity, f of x goes to positive infinity. And then on the right, y is pointing up as well. So as x goes to positive infinity, f of x goes to positive infinity. All right, determine the zeros and their multiplicities for the given functions. We're going to get into this quite a bit later on. But for now, we're just going to follow these directions. So I have p of x equals negative 1/3, x plus 2 cubed, 2x minus 1 squared. So in order to find the zeros, we need to set p of x equal to 0. So I'm going to have 0 equals negative 1/3, x plus 2 cubed times 2x minus 1 squared. And I'm going to use the zero product property, which we should be familiar with. Okay, and what that says is we can set each factor equal to 0. So I have negative 1/3 equals 0. That doesn't give me any zeros, okay? That just doesn't work. I have x plus 2 cubed is equal to 0. And I have 2x minus 1 squared is equal to 0. Okay, when I solve this first one, I'm going to have x plus 2 equals 0, because when I cube root that 0, it just gives me 0. I'm going to subtract 2. And I'm left with x equals negative 2. For the second one, same thing. I'm going to square root, and I've just got 2x minus 1 equals 0. I'm going to add 1. I've got 2x equals 1. Divide by 2. And I've got x is equal to 1/2. Okay, so I have my two x-intercepts, or my two zeros. However, we need to talk about multiplicities. So my first x-intercept is negative 2, 0. And that has multiplicity 3. And how I got that is because on this factor at the beginning, it has cubed to it. So it happens 3 times. Okay, my next x-intercept would be 1/2, 0. And this one has multiplicity 2, because up at the top, it had a squared on the parentheses. Okay, it doesn't ask us to, but if we were to sketch a graph of this, we're going to have a dot at -2 and a dot at 1/2. We don't really know how they connect, but we have a leading coefficient that is negative. So I'll write that down here. So our leading coefficient is negative, and our degree is 1, 2, 3, 4, 5. So our degree is odd. So if we have a negative leading coefficient that is odd, our end behavior is going to start here and finish here. Okay, we just need to figure out what's happening in the middle. So if I have a multiplicity 3, that is a cross point because it's odd multiplicity. Okay, and if I have a multiplicity 2, that's a touch point. Okay, so what that means is I'm going to cross the graph at -2. So cross at -2. And I'm going to touch at 1/2. So just touch. And it could be pretty sloppy. That's totally fine. Okay. All right, q of x equals 4x to the 4th minus 37x squared plus 9. Okay, this is crazy. We need to factor this before we try to do anything. Okay, so let's see if I can get it quickly. Let's try 4x times x. We need to multiply to get 9 and get a -37. So these are both going to be negatives here. It's going to be a 9 and a 1. Oh, and these are squareds because it's a 4th. Okay, and how I can check that really quick is if I multiply, oops, let me change colors. If I multiply this right here, I get -36x squared. And if I multiply this right here, I get -x squared. And those combine to give me my -37x squared. So this one's good. Okay, this can continue to factor. And when I do that, for this first one, this would be 2x times 2x, and then -1 plus 1. And this would be x times x, and +3, -3. Okay? Then we're going to be using our zero product property. And set each of those equal to 0. So I've got 2x minus 1 equals 0. 2x plus 1 equals 0, x plus 3 equals 0, x minus 3 equals 0. So I've got x is equal to 1/2, x is equal to -1/2, x is equal to -3, and x is equal to +3. Okay, and so if you look at the factored form here, none of those parentheses have exponents on it, none of them repeat. So these are all multiplicity 1. Okay, so I've got 1/2, 0, -1/2, 0, -3, 0, 3, 0. And then I'm just going to be shorthand about it, and I'm going to write all multiplicity 1. And so because they're multiplicity 1, they are all cross points. Okay, so when we go to graph, it's going to be an ugly sketch. But I'm going to have a dot at -3, a dot at -1/2, a dot at +1/2, and a dot at +3. Okay, our leading coefficient, they did give us a normal polynomial to start with up here. Our leading coefficient is positive, our degree is even. So our leading coefficient is positive, our degree is even. So our end behavior is going to be here and here. And they're all cross points, so it's going to be sloppy, but we just cross, 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 and finish up.